Hello, everyone. You are welcome to lesson 2 of trig. Okay, trig. And remember in lesson 1, basically lesson 1 wasn't trig. Okay, we were looking at more or less recall of previous words knowledge. And for you to appreciate the concept of trig, okay, you should be okay with what the Pythagoras theorem. So that's what we did as the introduction. But in actual fact, what we did wasn't trig. So it's today that we are going to look at what trig. So indirectly, this should have been, okay, lesson 1 of what the topic of trigonometry. Okay, so trigonometry. Okay, so quickly, let me take you through what we have on this on our screen. When need be, then I will throw little light on that. So trigonometry is a branch of mathematics concerned with or that studies the relationship between angles and side length of triangles. Angles and side length of triangle. That is all about trig. So trig, okay, studies the relationship between angles and length. But angles and length of what? Only triangles. So only a special form of polygon, which will be what? A triangle. Okay, so in particular, the trig ratio, or let me say trig function, relates the angles. And when I say trig, I mean trigonometry. Okay, so the trig functions relate the angles of a right angle triangle, okay, with ratios of its side length. So even with the triangles, okay, we are saying that for you to apply the trig function in terms of the trig ratio, okay, we are going to concentrate on a special type of triangle, which will be a right angle triangle. Okay, and here I'm talking about the trig ratios. But that's not to say that if your triangle is not a right angle triangle, you cannot use the concept of trig to deal with it. You can use the concept of trig, but not what the trig ratios. So very soon you understand, okay, perfectly, okay, what I just said. Okay, so it helps to find the missing or unknown sides and angles of a right angle triangle. So you can see that here I have restricted myself to, okay, right angle triangles. And because I have in mind that we are going to concentrate on the trig ratios, and trig ratios is particular or are particular to this special form of triangle, right angle triangle. But aside that, we have other means of employing trig, okay, concept to solve non-right angle triangle questions, which will obviously, okay, come to. So quickly, this is what we know. In JHS, remember, okay, I don't know, yes, some of you, if not all of you, this concept is known in JHS. You remember SOHCAHTOA, the mnemonic SOHCAHTOA, right?
Yes, please.
Yes. Okay, so we are going to make use of that. Okay, so quickly, let me see if indeed you remember. So whenever we talk of the basic trig ratios, okay, we have 3, which will be sine, okay, cosine, and tangent. However, sine, okay, is written in short form as SIN, and please, it is still pronounced sine, not sin. Is that clear?
Yes, sir.
Okay, so sine, cosine. So cosine, this will be cos. Then the short form will be tan. So sine, its short form is still sine, but the E will not come. Okay, then cosine, then what? And tangent. Okay, however, each of these ratios, that's why we call it, okay, trig ratios. And we know that anytime we are dealing with a ratio, we are looking at a quantity over another quantity. So all your whatever that I mentioned here, sine, cos, and what tan, they are all what ratios. So we'll be looking at what ratios of what concerning the size of what of the triangle, and in this case a right angle triangle. So every right angle triangle will have 3 sides. We all know. Okay, one of the sides. Remember in our previous lesson, I told you that one of the sides is usually fixed and it has a special name called the hypotenuse. Is that not it?
Yes, please.
Okay, and again, let me ask this same question that and see whether you remember. Okay, if this side, let me take the first one. If this side is the hypotenuse, what is the name given to the other two sides?
Legs.
Legs, very good. Okay, so now I think when I asked that question, somebody said opposite, adjacent, what have you, and I said that no, opposite and adjacent, okay, will be relative to an angle. If you don't have an angle in play, you cannot talk about opposite, you cannot talk about adjacent, because opposite is relative to a particular angle. So it is opposite a particular angle, then adjacent a particular angle. So please, once again, take note of that. So in this case, we know the mnemonics that I said, so katwa. So this mnemonic that you have here basically is to help you know the ratio for side, that of the cos and that of what the tan. Okay, with respect to the size of what the triangle. So whenever you have sine, and remember we said sine will be these three functions, and every function will depend on a particular quantity. However, the trig, okay, functions usually would depend on angles. So we take trig of angles. Is my point well made?
Yes, please.
Okay, so every trig function will be a function of angles. But here, if you look at this diagram or these three diagrams that you have, you can see that
Please, your line was breaking, so I couldn't hear you.
Oh, really? Please, is my line still breaking? Or is my line breaking?
No, please.
Okay, so please, if you are having that issue, the same issue, if your line breaks, then it means coming from your end. So disconnect and reconnect and see if you come with a better, okay, network stability. Okay, all right. Thanks for your understanding. So like I was saying, okay, trig functions of angle. So we take trig, okay, ratios of angle. So the angle here will be theta. So sine theta will be equal to, remember we said we use so O for opposite and H for hypotenuse, A for adjacent. So this will be opposite over hypotenuse. So it will be O over what? Over H. Okay, that's where we have what? Our so and car with yours. So it means car, the first one, the first letter, okay, is for the trig ratio. And the two other letters will be for the size, okay, for each of them. So car means I'm looking at cosine. So cosine, this short form will be cos. So cos of my angle theta will be equal to, again, remember the mnemonics, car. So adjacent over what? Hypotenuse. So A over what? Over H. Okay, and last but not the least, we have what? Toa, which is for tan. So tan, okay, theta, my angle will also be equal to toa, opposite over adjacent. So that will give me O over what? Over A. Is my point well made?
Yes, please.
Okay, so when you know this, okay, which we said we can easily use this mnemonics, okay, to, okay, make use of that, you are good to go in terms of what? The basic trig ratios. Okay, so, okay, Prof. Bliss.
Mr. Hackman, please, the first one that you gave us, sine is equal to opposite on hypotenuse. Is it different from the sine of theta?
The first one.
Yes,
Which first one?
the actual ratio as opposites on hypotenuse. Is it really different from the sine of theta?
No, it's not different.
How is it different?
Okay, so I don't know if I get you. I'm going to explain the way I get you. Okay, if that is not how, I mean, the question that you were asking, please come again, okay? All right. Okay, so we know, okay, from what you said, okay, indirectly, you are trying to say that I said sine, okay, is equal to what? Opposite over hypotenuse. Is that not it? And now I'm saying sine theta is equal to opposite over hypotenuse. Do I get you right? And what is the difference? Prof. Blaise, am I on the same page with you? That's it. Okay. So remember, okay, just for convenience sake that we write the sign. Remember, you don't take sign in vacuum. You take sign of angles.
Okay.
So this is just there for convenience sake, but we all know that sine will be sine of an angle. Sine, because your calculator, if you use sine, your calculator will demand sine of what? Okay, it will be an angle. Is that clear? So always there should be an angle. In any case, okay, remember I said you cannot mention opposite, okay, adjacent without, okay, introducing angle. So if I take this angle theta, you can see the opposite to the angle theta is this side of the triangle. Is that clear?
Yes,
It's my point, William. And adjacent to this angle is this side. So it means if I change my angle theta to this, okay, vertex, or if my theta is this angle, okay, will my adjacent still be this? Okay, what will this side be? If this is theta,
opposite.
it will be the opposite. And this time around, this rather will be what? The adjacent. Is that clear?
Yes,
So that's the more reason why I said the adjacent and the opposite are not fixed. Okay, they are relative to what? Your angle that you are considering. So the angle and the consideration. So here our angle and the consideration, you can see we are using theta. So when we come to theta, this is the opposite, and this will be what? The adjacent. Okay, but when I'm looking at, so I don't need the adjacent. I need only the opposite and the hypotenuse. That's why you can see, okay, the adjacent here. And when I'm looking at cosine, I need only the adjacent and what? And the hypotenuse. So that's why you don't see the opposite here, because I don't need the opposite, even if it is there. You get it? And same for tan. Tan is opposite over what? Adjacent. So you need the opposite and the adjacent. You don't need the hypotenuse. Okay, as simple as that. Point well made, my professors.
yes.
Okay, so quickly let's look at, okay, the following points that you are supposed to note. Okay, and this one, the first one, you know, I've indirectly said it. Hypotenuse is the side opposite the right angle and the longest side of a right-angled triangle. So it's always the longest side and it's opposite what? And that's why we said for every right-angled triangle, one of the angle is fixed, you know its value, which is 90. And the side opposite is the hypotenuse. The hypotenuse will equally be fixed. Okay, now let's come to B, which indirectly, the second one, not B, indirectly have equally addressed. So the opposite side and the adjacent side, they vary depending on where theta lies. I've said that, is that not it? So the side that will be opposite, that will be adjacent, is relative to your theta, where your angle theta will be. Then, okay, the last one, trig ratios are used to find, okay, one, the measures of one or both of the acute angles in a right angle triangle, okay, or in a right triangle for short. If you know the length of two sides of the triangle. So if I have a right angle triangle, okay, and I know two sides, let's say I know this side and this side, okay, I can use the trig ratios, okay, to find this missing side. In actual fact, if you want to find this missing side, you have to use the Pythagoras theorem. You can use the Pythagoras theorem to find this missing side. But once I know this missing side, or I even know these two sides, I can find, okay, the acute angles in the triangle. So that is exactly, okay, what this is talking about. And that explains, and if I have this situation where I have a right angle triangle, okay, so let me go strictly by the measures of one or both of the acute triangles. So in this case, I have this acute angle known of the triangle. So let's say X, this is Y. So if I know these two angles, okay, I'm more than able, okay, to find, okay, the size of what? Of the triangle. I'm in the best position to find the size, okay, of the triangle. So please take notes. And the same way, if you know the size, you are in the position to find the interior angles or the acute angle of a triangle. And that is exactly this what this one is talking about. Is my point well made?
Yes, please.
Okay, so basically, okay, for every triangle that we can apply the trig ratio on to find either an unknown side or an unknown angle, or unknown sides or unknown angles. First of all, that triangle, and okay, you should know one angle, okay, and one side. Okay, or in that triangle, you should know two of the sides. Okay, before you can solve the triangle. And in math, whenever we say you are solving triangles, I remember I said this when you did plane geometry 1. Okay, whenever you are asked to solve a triangle, it means find the missing, okay, sides as well as what the missing angles. So find the unknown sides as well as what the unknown angles. So if you want to find the unknown sides or known angles of a right angle triangle, we usually have to make use of the basic trig ratios, or we have to make use of these trig ratios that I have mentioned: tan, okay, cosine, and what, and sine. Okay, so quickly, let's move on to the real deal. Okay, so worked example. Okay, how best we can make use of the concept that we've learned so far to deal with the questions that we have here. Okay, so are you with me, my professors?
Yes.
Okay, so let's go with the first one. In the diagram below, angle BAC is 60 degrees. Okay, the length of AC is 10 centimeters. Find the length of AB and the length of BC. So in this triangle, okay, obviously you can see that one angle is known and one side is known. Okay, but the question, so once you know an angle and a side, like I just said, okay, you can find any unknown side as well as any unknown angle. But if I ask you to find an unknown angle, this angle C, okay, you can choose not to make use of the trig ratio because you know the sum of the interior angle should give you what, 180. So the trig you can ignore or not go through the concept of what trig. However, we'll use trig to see whether it will give us the same value. Okay, though it is not part of this question, but we'll just, okay, play with it. Is my point well made?
Yes, sir.
Okay, so now this is what we have. The question is asking us to find the length of AB. So the length of, in terms of this triangle, what will this side be? Will it be opposite or adjacent? Hello, opposite or adjacent?
Opposite.
This side, AB, is AB opposite or adjacent?
Adjacent.
It's adjacent. Remember, opposite will be this. So if you like, let's use this rough way. So you can use maybe O. Then this will be what? A for adjacent. Or let me use AD so that it doesn't go. So adjacent and opposite. Okay, OP. Okay, so now if that's the case, now you can see that you are looking for the adjacent. Okay, meanwhile, you've been given what the hypotenuse, and which trig ratio makes use of the adjacent and the hypotenuse. Go back to your mnemonics. So, okay, ka, okay,
cosine.
twice. So usually it's better. Okay, so you can see that the cosine involves the adjacent and the hypotenuse. So it means it will be convenient, okay, to find the length of AB using what? The cosine, okay, ratio, trig ratio. So in this case, I'm going to write, okay, so solution to question 1. Okay, I know that cos my angle 60 degrees should be equal to adjacent over hypotenuse. So go and pick your adjacent. Your adjacent is what? What you are looking for, which is AB. Am I right?
Yes.
Over your, what do you call your hypotenuse? And your hypotenuse is 10. Is that clear? So this goes to tell you that, okay, whenever you are doing your calculation, it's not necessary to write opposite over adjacent or adjacent over hypotenuse, what have you. Okay, just go and look for what is occupying the opposite, write it there. What is occupying the adjacent, write it there. What is occupying the, what do you call it? The hypotenuse, write it there. Is my point well made?
Yes, please.
You are matured. The opposite over, in this case, the adjacent over hypotenuse, you should have it in your mind. Adjacent, let me go and look for the adjacent, and that is BA, I don't know, or AB. Okay, what is there for the hypotenuse? 10. Okay, somebody could have written, okay, AC. Then the next one, do the substitution. But once you know its value, substitute straight away and go. It's when you don't know the value that you use, okay, the letters. Is that clear?
Yes, please.
So it means now I'm going to get, this implies that, okay, 10 cos, because I'll cross multiply, cos was 60 degrees. And when you are taking, don't forget the degrees. Okay, don't just write cos 60. Your calculator, because your calculator function, and I believe all your calculator, if you look up there, you see the D there. Okay, do you have the D there? Then it means your calculator is in the degree mode. So any course that you take, it will be because of the angle in degrees. Anything that has to do with angles, okay, your result will be in degrees. So in this case, this will be equal to what? AB, the length of AB. So in this case, I'll write, therefore, the length of AB, okay, will be equal to the first part of the question. So you use your calculator to do this. Let's go. This one is just calculator work. I'm waiting, my professors. Oh, can you hear me?
5.
It will give you 5 because cos 60
That
is
one
half.
I got 5.
Yes, it's because cos 60 is half. Okay, so 5. But you can see that there is a unit, so don't forget. So it will be 5 or centimeter. Is that clear?
Yes.
Okay, so Prof. Blaze.
Mr. Hackman, please. I went off. Are you guys doing are you using the course because you are finding AB and AB is adjacent?
Very good. Yes, you go for, okay, the trig ratio involving your, well, the one known, okay, and the one unknown. So you're involving your unknown and the one, okay, known.
Okay.
All right.
Yes.
Okay. So that was it for, so maybe the second one, the second part of the question, okay, you can still be on track. So in this case, okay, and now we know we are looking for, okay, BC. So for BC, what are we supposed to? BC is this, and BC we know is opposite. Is that not it? So the unknown is opposite, and the known is what? Is the hypotenuse. So we need to go and look for the trig ratio involving this your unknown, which is the opposite and the known hypotenuse. So which of the trig ratios here we involve the opposite and the hypotenuse? Sine, is that not it?
Sine.
And so you go for sine. So you write sine of your angle. Do you know your angle? Yes, the angle is 60. Okay, the angle that you use to determine the opposite and the adjacent. Okay, will be equal to, remember, opposite, okay, which is what? We know that we don't equally know the opposite. So the opposite is BC, am I right? What I'm looking for over the hypotenuse is what? Is 10. So in this case, we are going to get what? Okay, this implies that, okay, BC, let me write it here, BC, the length of BC will be equal to 10, okay, sine 60. I hope you are with me. It's the same as writing sine 10 sine 60 is equal to this. So now I'll come and write therefore the length of BC, okay, will be equal to, so I'm waiting for your calculator value. Hello, is my point well made?
8.660.
Come again.
8.6602.
6603. I hope you check the next digit.
Yes, please.
Okay, and it will be in centimeters, is that not it?
Yes, please.
But you can see that there's an approximated value. And you know that when you are approximating, your first approximation should be what? 4 dp. So for what you gave me an indication that, okay, you know. But anytime you approximate, don't forget to indicate your approximation. So, okay, in brackets 4D. Affirm. Hello, is my point well made?
Yes, please.
Okay. Okay, so this one, okay, Prof. Ama.
Mr. Akman, could we have used the fraction of sin 60 so that we will not involve any approximation?
Well, you can, okay, but because at this point, you are supposed to, you can use your calculator. In that case, your answer will be in the said form. Is that not it?
Yes.
So you can. But because, okay, like I said, this is just a calculator where you can do this. However, okay, if it is an objective question and the answer is left in the said form, but even this one, it can give you answer in the said form. The calculator should be able to give you answer in the said form.
Mr. Akman, I did, I got the set.
You got the said. So if it is the said, please leave your answer in the said form because that's an accurate answer. So let me skip this. Then give me the said version.
5√3.
5√3, okay, cm. So it's better you conclude with this. I thought maybe he gave you this straight away. So you know, I've told you, avoid approximation if possible. And here, it is possible for us to avoid approximation. So you avoid. All correct.
Yes, please.
Okay, so it means I'm rather going to take this as what? As the answer. Okay, very good. Now let's look at, remember I told you that we'll play with this. Okay, what is the size of the angle here? Angle ACB or BCA?
Yes.
30.
Yes.
By inspection, it is 30. Give me some few seconds. Hello. Okay. All right. So you know it is 30, is that not it? By using the sum of the interior angles of a triangle. This is 30, is that not it?
Yes, please.
Okay, I want us to use the trig ratio. We'll come to a situation. Now we are looking at the usage of the trig ratios when you are given an angle and a side to solve, okay, for the unknown size. Now we are going to look at solving for an unknown angle. If you can solve for an unknown angle, then you need to know at least 2 of the sides of the triangle before you can find an unknown angle. So here I'm assuming we have found the adjacent. The adjacent gave us what? 5, right?
Yes, please.
Okay, so I'm assuming we know this to be 5 and this to be 10. So let's use the appropriate trig ratio and see whether we will get this angle to be what? To be 30. So we know the adjacent, 5. We know the hypotenuse. So which trig ratio involves the adjacent and the hypotenuse?
Cosine.
Cosine. Is that not it? However, take note, we are looking for this angle. Is that clear? So let me call this x. If I'm looking for this angle, this becomes what? The 5 that you have here becomes what?
Opposite.
Hello, are you with me? It becomes what? The opposite, right?
Yes, please.
Remember, your side is relative to an angle. And this becomes the adjacent, but this is still 5. We found it using this, it will still 5. It will still be 5. So if that's the case, then it means this time around, it is the opposite and the hypotenuse that I'm going to use. And which trig ratio involves the opposite and the hypotenuse?
Sine.
Sine. Okay, so I am going to write sine. My angle, which this time around, I don't know, x, should be equal to opposite, which is what? 5, am I right? Over the hypotenuse, which is 10. So that will give me 1/2. Is that clear?
Yes, please.
So it means sine x is equal to 1/2. And please take note, on your calculator, you can always find the angle. Let me see. Okay, I saw some messages there, but it seems, okay, gone. Okay, so now this is what I was saying. Because you know, okay, that sine x is equal to this, we can always find this, okay, x by taking the sine inverse of what you have here. It's just like dividing by sine. So we'll say that your x here will be equal to sine inverse, which your calculator has that function of 1/2. Okay, so those of you, you can see that the sine inverse, I think, is on top of your sine key. So if you want to access it, you have to, okay, press the shift, then you press that key. So you see the sine inverse appearing on your screens. Are you there, my professors?
Yes,
Yes.
please.
Okay, so find the sine inverse of half. Okay, if it doesn't give you 30, okay, you have to check the expiry date of your calculator, you throw it away.
Please, it's 30.
Okay, so by 30, you know that the angle is in degrees. You get a point. So you see the usefulness and the validity of the trig ratios. But I said, with this one, if you know this angle and I asked you to find this angle, unless maybe the question specifically told you using the trig ratio. But if the question, the instruction is not this explicit, okay, then this is what you do. You use your sum of the interior angles, period. Don't use the trig ratio because you know that if you do that, you write more. This one, just by inspection, you can even get the answer. Okay, so I guess my point is well made. Now let's go and look at our second question. Okay, similar to what we just did. Before we have our second question, or we look at our second question, any questions? Hello, any questions? Are we all fine?
Yes, please.
Okay, great. So now if you are fine, then we are going to look at this one. We are asked to find the length of AB and the length of AC. Okay, so let me see question 2. Let me call you, okay, at random to see those who are with us. Okay, so let's see. Who will be on my radar? Okay. Prof. Ellen, let's go. We are looking for AB. So guide us as to how we can find our AB. Prof. Ellen, are you there? Please unmute and respond. You know the rule. Otherwise, I will give you a yellow card. I will come back to you again. Okay, so Prof. Ellen is not responding. So I'm assuming she's left without permission. Okay, or she is sleeping. All right. Okay, so Prof. Eura, let's go. Prof. Eura, are you there? Eura, are you there? Okay, so Eura to yellow card. Okay, Prof. Let me see. I've seen a message. Okay, whether she is the one. Okay, quickly, let me check. Eura, your background is noisy. Wow. Okay, so I've told you, you have to be where you can answer questions. Okay, so Prof. Cardodo, let's go. Hello?
Yes, sir. We use the formula sine.
Sine, okay, why sine? Which side are you looking for, AB?
Yes, sir. So that's the it. So course rather.
So I say, see, for you to be on the safer side, you know that the money, so immediately you see the question. So, okay, you just write it. Okay, ka, okay, toi. Okay, to guide you. So you are looking for what this side, if you look at this angle here, let's go. It is the adjacent.
So
and what are you giving?
We're giving what they call it,
The
angle
side
to be
here.
60 degrees.
No, the side here. What is it? The opposite or the adjacent or the hypotenuse?
Opposite.
The opposite. So you know the opposite. Okay, then you are looking for the adjacent.
Yes,
so
sir.
which one will you use?
We use Twa.
You get it?
Yes, sir.
So always let this make your work very easy for you. So opposite, okay, adjacent, and I can see the opposite adjacent, okay, is here. So that tells me that I have to use what? Tan. So let's go.
So tan 60.
No, it's not
degrees.
60. Check.
56 rather. 56 is equals to the magnitude of 16. Oh.
Magnitude of 16.
Yeah.
Oh, unless you say magnitude of BC, but the magnitude is here.
Oh, okay, sir. So 16 over the magnitude of B A. Yeah.
Okay, which is AB. Yeah. Magnitude is the same thing. Okay, so that's all that I wanted you to know. So, okay, at this point, I will carry on from here. You are doing well. So take your time, okay, and protect our marks for us. Because immediately you go for the wrong trig ratio, you are doomed. Okay, all right. So now what do? We know we are still looking for AB. So here we are going to cross multiply. So this will give us AB, the length of AB, or let me write this implies. Okay, tan, okay, 56 degrees will be equal to 16. Am I right?
Yes, please.
Okay, now we are looking for AB. So we write it again, divide by tan 56. Okay, and at this point, please don't use your calculator, okay, to find the approximate value of this. No, your calculator, you use it once. So we are going to have AB length. I'm writing it again, tan, okay, 56 degrees is equal to 16 all over tan 56 degrees over tan 56, okay, degrees. So in effect, I'm going to get my AB, okay, the length of AB, therefore, will be equal to, now you use your calculator to do the 16 over tan 56 degrees. So you get your value straight away with only one approximation. Is my point well made?
Yes, please.
Yes, please.
Okay, so, okay. Prof. Ellen, well noted. Okay, right. So I'm waiting for you. You know that a calculator works usually will be for you.
10.79.
Come again, 10 points.
79 centimeters.
10.79. Was it exact?
7921.
Remember, I said when you are approximating, your first approximation should be
4 dp.
dp. Please don't forget this. So I don't know where the 2 dp is coming from. If your 2 dp is an exact value, then you write it. But if you are going to approximate, please, if the question didn't tell you to approximate to 2 dp, okay, your first approximation should be 4 dp. Even if the question asked you to approximate to 2 dp, your first approximation should be 4 dp before you take it to your convenience, or in this case, the required approximation. But here, there is no required approximation. So let's go for the 4 dp.
10.7921.
921. I hope you check the next digit. So the unit there is centimeters. But because this is approximated, you don't forget to indicate your approximation, or dp. All correct, my professors.
Yes, please.
Yeah.
Okay, very good. So that will be it for only AB. Okay, so I want someone to guide us to do AC. Okay, so let me see if I can, okay, call, let me see whether, okay, so 2C, Prof. 2C, let's go. Prof. 2C. Prof. 2C, are you there? Let's go. Don't tell me, I told you not to join. I told you not to join the class if you still have issues with your audio. So once you join, it means you have resolved your issue. Okay, all right. Prof. Samuela, hey, I think I can hear you. It's better. I can hear some. Tusi, are you there? Okay, it's okay. I can't, it seems I get the sound, but not exactly what you are trying to. Okay, so Prof. Samuela, let's go.
Sir. Sir, so we'll use sine.
You use sine. Okay, why?
Because we have the opposite and we are looking for the hypotenuse.
Very good. Okay, so and
Sine
is 56 degrees
is equal to magnitude of AC on 16. This implies that
very good.
magnitude of AC is equal to 16 sine 56.
Okay.
56 degrees here.
So I guess you don't have a calculator.
Yes, sir.
You see, I'm smart. Okay, so therefore, your length of AC, okay, will be equal to, use your calculator, whatever that you get, you attach. Okay, Prof. Namdi.
Sir, please, I want to ask a question.
Oh, go ahead.
Sir, please, since you found the opposite and then the adjacent, why don't you use Pythagoras theorem to find that?
You can.
The AC.
You can. But you can see that if you want to use the Pythagoras theorem, you are now going to start with, okay, by the Pythagoras theorem, you know it. And the volume of work in that one will be more than this. I think you agree with me.
Yes, please.
So where you can use the trig ratio, use the trig ratio instead.
Okay, thank you.
You are welcome. Okay, Prof. Ama Zakuma.
Oh, say Jakuma.
Hey, Jakuma,
Okay.
forgive me. Okay.
Okay. So please, the AC is the hypotenuse, but sines and functions for to opposite first over hypotenuse. But if you hypotenuse first,
very good. Very good. Okay, so this is where you have to be very, very careful. Okay, so once you know your trig ratio, okay, you know the first one is supposed to be the numerator and the second one, okay, must be the denominator. So once you write it this way, you shouldn't get it wrong. Take notes. So you said, okay, that one, Samuela, you were the one, right? You said sine, you have to use sine because yes, you know the hypotenuse and you are looking for the hypotenuse and you know the opposite. So fine. But remember, we said sine is equal to what? The opposite over hypotenuse. It's not the hypotenuse over the opposite. You know, A over B is not equal to B over A. True or false?
True.
True, it's not always, unless A is equal to B. Okay, so at this point, immediately you set this equation, okay, and you write it this way, you are doomed. So take note of that. Is that clear? I guess, Prof. Liz, I guess you are equally going to draw my attention to that.
Yes, please.
Okay, so at the end of the day, I was going to ask, do you see anything wrong with the solution? Okay, if you said no, I would have moved on. And that would have convinced me that you are not, okay, really following the concept, because I believe you are smarter than this. So please take note, this rather should be 16 over the length of AC. We now all agree. So it is the opposite. So it means the whole of this will change. Oops, I think I can leave the other one there. So, okay, all right. So this will rather be 16 over the length of what? Of AC. Okay, and I guess that one should go. So it is similar to what we just did. I hope you agree with me. The algebra will be similar to what we did above. Is that clear? Okay, so now again we cross multiply. So you get the AC length, okay, then sine 56, okay, degrees, okay, is equal to 16. Okay, so at this point we are looking for AC. We write it again, okay, before we divide by the sine 56 degrees. So over sine 56 degrees, okay, then over sine, okay, 56 degrees. So whatever your calculator gives you, you conclude with it. So therefore, the length of AC, okay, will be equal to 16 over sine 56. I'm waiting, my professors.
90.2995.
Okay, don't forget your CM. Okay, that's the unit. Okay, and don't forget your approximation as well. So that will be 4 dp. And your unit before the approximation. Okay, you indicate your approximation. If you the other way around. Okay, all right. Point well made now.
Yes, sir.
Okay, so let me see the next question. Okay, so this one is supposed to be yours. So when you come back from I think let's do a situation where you are looking for an angle so that when you come back, we'll look at a different concept altogether from our water break. So this one indirectly we've done, okay, one indirectly. So let's look at a situation. Remember in our first two examples, okay, we were given an angle and a side and we were asked to find, okay, side. So with this one, you are given two sides and you are asked to find an angle. And even in the first one, we did something of the sort, just to verify a certain, okay, concept or value or fact. So in this case, okay, the same thing. The angle that we have here, this is the angle theta. That's what we are asked to find. This is the opposite, okay, and this is what the adjacent. Am I right? So if I want to find theta, I have to make use of the trig ratio that involves opposite and what adjacent. So let me come to, as we mature, some of these things, you don't have to even write what I'm going to write. Okay, so I'm assuming we are not mature. So it will be, okay, so, okay, ka, okay, toi. Okay, so opposite adjacent, and that will be for tan. So I'm going to write question number 4, and I'll write tan, okay, theta will be equal to what? Opposite, remember, so be very careful. Opposite is the first one, so that will be 3 over the adjacent, which is 4. Do you agree?
Yes.
Okay, so now we know how to find this angle. So I'll write, okay, theta will be equal to tan inverse. Okay, we are finding, so you come and take tan inverse of this value, which is 3 over 4. Okay, if you can use your head, you use, otherwise use your calculator. Okay, so let's go. Therefore, theta is equal to
36.86.
36.8. 36.86.
86.99.
99. I hope you check the next digit.
Yes, please. The next digit was 9.
The next digit after the 9.
No, it was 8698.
Okay, all right. So now I'm going to write, okay, 4 dp. Do you think there is something missing?
Theta.
What is
It's
the degrees? Remember, it's an angle. And here, your angle here is measured in degrees. So don't forget the unit. Is that clear? Okay, very good. Okay, so I believe with that, you should be able to do this as well. So with this one, you are asked to find x. Okay, sometimes the question can ask you to find tan theta or cos theta, or in this case, find cos what x. Okay, so but let's deal with the question the way it is. Find x. So here, what are we giving? The opposite, is that not it? We know the opposite and we know the hypotenuse. So which trig ratio are we going to use?
Sine.
Sine. So it will be sine. Okay, our angle x degrees will be equal to what? Remember, it will be sine, we said, is opposite of hypotenuse. Opposite is 5 over the hypotenuse, which is what? 30. So at this point, your x, this implies that my x will be equal to sine, okay, inverse of what? Okay, 5 on 30. And if your fraction here can be reduced, you write the reduced version rather here. Is that clear? Same for this one. So maybe if it was
Yes,
5
please.
over maybe 15, you can reduce, you reduce, or 3 over whatever you reduce. So at this point, okay, we are going to get there for, okay, our, so s degrees is this. So x will be equal to, I'm waiting. There is something important here. That's the more reason why I'm doing this question, and very soon you will know. If you don't take care, all of you will be victims. So I'm waiting for the value, then I will make my point.
Please. 22.61.
22, so 22 points.
9.
9,
9.
9 again. Okay.
Yes, please.
Okay. All right. Are we done? Apart from
No,
the
please.
4DP, don't forget. What else is missing?
Degrees.
Degrees is missing.
No.
Mr. Hartman.
Yes.
Please, the X already had degrees, so I don't think you bring it.
Very good. So this is it. You were asked to find the x. So if maybe in this case you are saying that s degrees will be equal to this degree, so it means in actual fact s is equal to this without the degree. Remember I told you this when we were doing plane geometry 1. Yes. So take note of this. Sometimes the question might look easy, but these basic okay tricks, okay, will be what will deny you of certain marks if you fall victim, if you don't take care. So here x rather will be what you have there without the degrees. If the whole of this was x without the degrees, okay, then it means your s you conclude with the degrees. You know this, is that not it? So let me write implication here and come and write, therefore, x will be equal to 22.6199, which I could have done so here if I'm matured. And here you don't indicate 4DP because we've already stated here that it's 4DP. Okay, if you are using this, okay, approach, take notes. Point well made, my professors.
Yes.
Okay, so at this point, I think I will give you your water break. Okay, so please go and have your water break. Okay, so welcome back from the water break. Okay, so this will be your next question, which I believe you should be able to do it. So we are going to skip. Okay, similar. Only that the orientation is quite different from what you have, but you know, this will be the opposite. If you are looking at this, so this will be the hypotenuse, forgive me. If you are looking at this angle, this becomes the opposite. Okay, and the question asks you to, so you know the hypotenuse, then what's the opposite? So obviously, you know, opposite hypotenuse, that would be so. So you have to use sine x degrees is equal to, you get a point.
Yes, please.
Okay, and this one to opposite, so sorry, hypotenuse, then the adjacent, is that not it?
Mm-hmm.
So which trig ratio do we use? In finding y, what will be the appropriate trig ratio? You know the hypotenuse, you know the adjacent, because this is the opposite.
Cosine.
Okay, cosine, very good. So you use cos and you are good to go. Okay, so now we are going to look at questions in a different form. That's not entirely different from what we use the same concept. Okay, all right. So now brace yourself and let's look at how best we can deal with these questions. So this is what we are given. Cos x is equal to 1/3. So indirectly what you have here, let me put it this way, is, yes, a trig equation indirectly. Okay, so if cos x is equal to 1/3, where x is between 0 degrees and 90 degrees. And take note, when we are dealing with Fermat trig, usually we restrict ourselves to the first quadrant. By that is what I mean. In trig, okay, this is how we define the quadrants. So this will be your y-axis, then your x-axis. Okay, in trig, okay, this becomes your first quadrant, quadrant 1, your second quadrant, your third quadrant, okay, and your fourth quadrant. Okay, and trig, angles are measured, okay, in this direction. Okay, so it will be anti-clockwise. Angles are measured anti-clockwise from a baseline. And for every angle, every, what do you call it, angle that is formed, angles are formed between two lines. So here, one of our baseline will be the positive x-axis. So angles are measured, okay, from the positive x-axis in the anti or anti-clockwise direction. So please take note. But here we are looking, so if you take this quadrant, we'll say that your angle here, okay, is between, this is what we call this 0 degrees, this will be 90 degrees. Okay, this becomes 180 degrees. Okay, so this becomes 270 degrees, and 0 degrees will coincide with 360 degrees. Okay, so let me disable my notations. Okay, all right, so this is what we have. So here, your angle in the first quadrant will be between 0 degrees and 90. In the second quadrant will be between 90 and 180 degrees. In the third quadrant will be between 180 and 270. And in the fourth quadrant will be 270 and 360. Is my point well made? However,
Yes,
if you are told your angle is between 0 and 90, it means your angle is here. And in this quadrant, I'm going to say something here. And this one is specifically for the relative math student, but Fermat, if you know, is better. Okay, in this quadrant, all your trig ratios are positive. So all. So cos is positive. Cos of any angle here, okay, is positive, will give you a positive result. Okay, sine of any angle between 0 and 90 will equally give you a positive result. Okay, tan of any angle between positive and negative will give you, so between 0 and 90 will give you, okay, positive. So if you like, take your calculator and let's do this quickly. Okay, fine. Okay, sine 30. 30 is between 0 and 90. Is that not it?
Yes, please.
Okay, so sine 30 degrees, what do you get? I only want the sign of your value. Is your answer positive or negative?
Positive.
Okay, then take cos of the same angle, 30. Positive, right?
Yes.
Okay, then tan of the same angle, 30. Okay, it's also positive. Here we have what we call another way, what we call the cast rule. But it's because of time that I am, okay, bringing other than that. But I will let you verify. Here the A, okay, in the cast, so what we call the cast rule. The A means all will be positive. So in this quadrant, all the trig ratios will be positive. Okay, if you see S, S is for sine. So in this quadrant, only sine will be positive. Okay, in this quadrant, only tan will be positive. So it means the other two, okay, cos and sine will be what? Negative. In this quadrant, only cos will be positive. Okay, the other two will be negative. So I want us to verify the second quadrant one. The rest, you can do it later on your own. So find any angle between, let me go for, okay, 120. 120 is between 90 and 180, you agree? You agree? Okay, so find sine 120. Okay, cos 120, then tan, and the degree is tan 120. I'm waiting. Okay, I need only the sines. Sine 120 will give you a positive result, am I right?
Yes, please.
Okay, so this will be positive. Cos 120.
Negative.
Negative. Tan 120.
Negative.
Negative. So indeed, you can see that in this quadrant, it is only sine of an angle in this quadrant that will give us positive. Okay, the other two will be negative. So you can verify for the other two. Is my point well made, my professors?
Yes.
Okay, so here, just by virtue of the fact that, okay, sine of any cos, let me restrict myself to this. Cos of any angle, so cos x, because x is in the first quadrant, I know that cos of x will give me a positive result. That's why it is 1/3. But this will be the ratio. But the ratio, you can see that is positive. Okay, so once cos of an angle is giving you a positive ratio, then it means, okay, your angle, okay, is either in the first quadrant or in the fourth quadrant. Because it's in the first quadrant that you get your cos to be positive, and what in the fourth quadrant that your cos will also be positive. But here we are told that it's in the first quadrant. Okay, so in core math, usually when you are not given the quadrants and you know the trig ratio, you assume that you are dealing with the first quadrant. Is that clear?
Yes, please.
Okay, but here the quadrant is stated. So what are we supposed to do? We are supposed to find sine x and what, and tan x. All right. Okay, so this is all that we need to deal with. Okay, I mean, do to deal with this question. So solution to question number 8 is so easy. Don't worry at all. So given, you extract what you are given. You are given cos, okay, x is equal to 1/3. Am I right? And if you like, you can attach this as well. Okay, and after in relative math, strictly will ask you to attach because the condition might change. Okay, but in core math, I've told you, usually the condition will be this. So you let's attach. Okay, this is the first one. So you, as we always do, handle it not the matured way. Okay, then as your understanding is perfect, then you move on. Okay, you can see that if I'm looking at cos, okay, cos, the ratio is what? So we are looking at SOHCAHTOA, am I right? Okay, so this is all that you need to do. Don't worry at all. Okay, so if I'm asked to find sine x, then tan x, okay, I know that cos will give me the ratio here. I know that the ratio here is what? Cos is what? Adjacent over the hypotenuse. Is that not it? Okay.
Yes.
Okay, Prof. Aduma.
Mr. Hackman, please, did you deliberately write 90 degrees?
Forgive me. It wasn't deliberate. This time, right, it was not. Okay, it wasn't. Okay, you know, if it is, I will tell you. All right. Okay, it wasn't. Okay, so thanks for drawing my attention to that. So now my question. Okay, we know, okay, that cos is what? Adjacent over hypotenuse. So it means in the triangle that you are going to consider to find your cos, that you consider to find your cos, x. Okay, in that triangle, the adjacent was 1 and the hypotenuse was 3. Do you agree? Or is 3?
Yes, sir.
However, if you are looking at sine, if I want to find sine of x, you can see that I will need the opposite. Though hypotenuse is known, opposite is not known. Is that clear? So I have to find my
Yes.
opposite before I can find my sine of what? X. And also before I can find my tan of what? Of x. So this is all that you need to do. Come and draw your right angle triangle. That will help you find, okay, your opposite. So here, my x, I'm putting my x here. Someone can put the x here, but usually, traditionally, we put it here. So this is your x. But cos x, if cos x is equal to 1 over 3, then it means cos we said is adjacent. So the adjacent is 1 over the hypotenuse. The hypotenuse is 3. So this was the right angle triangle that we're dealing with. Remember where we are coming from. Is that clear?
Yes, sir.
Okay, so this means that I need to go and find this. Okay, so if I want to find this, I have to use Pythagoras theorem. You cannot use trig ratio to find this because you don't know an angle. Is that clear? So you set out to look for your opposites. Okay, this value. So in this case, I am going to write, okay, by the Pythagoras theorem. Appreciate the man. And remember I said, okay, it's S apostrophe theorem. Okay, what are we going to get? We are going to get, in this case, this is the hypotenuse squared. So let me call this maybe, okay, which value should I call this one? Okay, which letter? Okay, let me use A. Is that okay? Or you can use any letter of you can even label your triangle if you like. So I'm going to get 3 squared should be equal to A squared plus 1 squared. Do you agree? So 9 should be equal to A squared, okay, plus what, 1. Okay, so let me write my A here. Okay, so at this point, my A, I will move this one. So I will get 9 minus 1, which is 8, is equal to A squared. Is that clear? So my A squared, root of that will be equal to root of what? 8. Okay, so that will give me my A. Remember, it's length, so I don't introduce plus or minus. Okay, so that will give me
2.
Okay, so we are going to get 2 root what? 2. Okay, now here there is no unit, so you don't attach any unit. Okay, if you like, you can write units. Okay, so now we know A. Once we know A, we are in a comfortable lead. Okay, so I am going to find whatever that. Can this go? My professors, can this go?
Yes, please.
Okay, so let me clear that. Oh, I should have even cleared the one, okay, below. But don't worry, once you see you agree, you can go. I can clear it. Okay, so now we know all that we are asked to find, only that some of them will involve simplification after substitution. Okay, likely. So in this case, now I will come and write, okay, what I have here. So, okay, this implies that, but we know from the sign, we're asked to find sine x. Okay, sine x will be equal to, we know opposite over what? Over hypotenuse. And what is our opposite now? Opposite is what? A. Okay, over the hypotenuse, which is what? 3. And as you mature, you could have put the value there straight away. So it means I'm going to get, therefore, my sine x will be equal to opposite, which is what? 2 root of 2 over 3. Is that clear? And remember, in this question, okay, we didn't do the right, and I maybe thought you would do it. We should have underlined said form. So if you approximate, you are doomed. You will not be considered at all. No mercy. Because we said you should leave your answer in the said form. Is that clear? And okay, we are supposed to find tan x. So tan x will be equal to tan. Okay, it's opposite over adjacent. So opposite is what? 2 root of 2 that we found. Okay, over the adjacent, and that is 1. So therefore, tan, okay, x will be equal to 2 root of 2. Is that clear? Okay, any questions at this point, my professors, before we move on to the next one?
No.
Okay, so quickly we move on to the next question. So the next question, this is what we have. Okay, Prof. Lynette, I guess I have to go back.
Please, can you decide to leave your answer in decimal?
Oh, no, you can't. Remember I said this. Look at this. So you see why I tell you that when you read question, take your time. You should always have your plan. Once you've been under my teaching, there are certain marks that you shouldn't lose. Because I always warn you, I've given you all the tricks. Okay, all the information that we know. So in this case, you read a question, you underline set form. So once you have underlined, I've told you in maths, anytime there is a form that you are supposed to leave your answer underlined. So having read a question, you saw this, you underline. So now you move on to solve. So don't think it's the usual way. Okay, don't think the question will be the usual. Pay particular attention to the wording of every question, every sentence, every word. Take note of that. Okay, to protect, okay, our low-hanging marks, what I call our low-hanging marks. Okay, so now that is clear. If you leave your answer in any other form, it will not be taken. If it was open, but even if it is not, it wasn't, or it was open, let me put it that way. If it was open, I've told you, avoid, okay, decimal if possible. So in this case, it would have been better you leave it in this form, this form. You only rationalize when there is a denominator containing a set. You know all the tricks, but this one is exact. What do you call it? Conclude with this. Conclude with this. It's exact. Even if you are not told to leave your answer in the set form. Unless maybe the question said you should approximate. Don't approximate. Point well made.
Yes,
okay,
please.
so I can see a couple of hands up. Okay, that was from Prof. Lynette. Matilda, Prof. Matilda.
Mr. Hackman,
Mm-hmm.
please, what was the use of the x is less than or equal to 90 degrees? What was the use in the question?
Okay, the use in the question was that, okay, because the x is, this x is between 0 and 90. It means if I find tan of x, my result should be positive. Okay, if I find, what do you call it? The other one was the sign of x, my result will be positive. So assuming this question, I could have put it, only that I told you that in core maths, we usually restrict it to the first quadrant. But assuming for the flexibility of it, assuming maybe, I said the fourth quadrant, we have cause to be positive, is that not it? So assuming maybe your interval for the x was this, between 270 degrees and 360 degrees. Okay, cos of any angle between 270 and 360 is positive. So it means my question is not flawed because cos of x is giving me a positive result. Is that clear? Irrespective of the numbers in the ratio, I have positive. Is that clear, Prof. Matilda?
Yes, please.
I am varying the question. So there is a variation, a little variation. Now, so in this case, okay, because you know that we are looking at this quadrant, when you find the sign, okay, if you come and find a sign, you cannot conclude with positive because you know that in sign of this angle, which is in this quadrant, remember the cast rule. Okay, in this quadrant, it is only cos that is positive, is that not it? So when you wrote sine x is equal to, it would have been minus a over 3 because you know your answer must be negative. You get the point. So in that case, it will be minus this over that. And the other one, the tan 2 will be minus because in this quadrant, okay, tan, your answer must be negative, not positive. Martin, is my point well made?
Yes, please. Thank you.
Okay, so this is basically supposed to tell you the interval here is supposed to tell you, okay, the sign for your trig ratios, that's all. Okay, all right, so if that's the case, then I can. So it was a good question anyway. All right, so let's look at, so this one too. Okay, so similar to what we just did, only that, okay, this time around, the numbers in the ratio different and our trig ratio equally different. So it's the same thing, solution, question number 9. Okay, what are we giving? Okay, tan x is equal to 4 on 5. Okay, then you can ignore or attach because usually. Okay, so if it's between 0 and 90, you can ignore, but any other, don't ignore. Very important because 0 and 90 is the usual thing. So the unusual, don't ignore. So at this point, I need to find sine and cos. But I know, okay, that before I can find sine, let's come and do our rough work for the SOCA tour. SOCA, okay, tour. That will guide us as to what to do. As you mature, you can always do this mentally. So tan will give me opposite and adjacent. Okay, but so and ka will involve hypotenuse. So it means in my triangle, I will need the hypotenuse. But that same triangle that you are giving it tan. So you come in. Okay, draw your right angle triangle. And please take note, you cannot use your free hand, okay, to draw this triangle. Use the appropriate, I've told you. And it should also be in pencil if possible. So now, my right angle triangle, okay, tan gives me the opposite, and let me fix my angle. My angle here is x. Okay, tan is opposite. So opposite is what is occupying the numerator. So opposite to this is 4. And it's opposite of adjacent. So the adjacent is 5. So the adjacent to x will be here. So you don't know the h. Is that clear?
Yes.
Okay, so in this case, if you like, you can use h or what have you. So what do we have? So I can say that by the Pythagoras theorem, I hope you are following my professors.
Yes, please.
Okay, so Pythagoras theorem. My handwriting is not that okay. It's for a reason. I'm writing fast. Okay, so what do we have? Okay, Prof. Ama.
Mr. Akman, please. This time, why didn't you extract the 0 less than greater than x?
I guess maybe you were not listening or your network, okay, had an issue. I said if it is the usual, you can ignore. That's between 0 and 90, but if not, you have to write it. Any other quadrant, you have to. So that doesn't mean if you can write it, okay. Only I'm saying that if it's the usual, ignore because you know that whether you write it or not, it will not change. You are dealing with positive, positive, positive.
Okay.
Right. Okay. So now what do we do? Okay. So you will do the Pythagoras theorem. Find h for me, and that will give you 3. Am I right? So h will be equal to 3. Am I right?
Yes, please.
Okay. So 3. All right. So in this case, if you solve, you get your h to be equal to 3 units. Okay. So at this point, I can go and say that I think I use capital H. Okay. So you can equally use that. Okay. So I can go and say that, okay, but, or I can even write therefore, okay, tan, the first one is sorry, sine, okay, x will be equal to. So sine we know is opposite of hypotenuse. So what is your opposite for? Over the hypotenuse, which is what? Which is 3. Okay, so in this case, I know this will be equal to, okay, because usually we are dealing with a ratio. Okay, here I'm changing because, okay, of our usual one. So 1 whole number 1/3. But because this one we are dealing with a ratio, you can choose not to change it to mixed numbers. So that's why I said, okay, the young will know the rules, the elderly will know the exceptions. Because a ratio is always supposed to be a number over another number. But if you change, it will not be costly. So you can still go by our usual. Is that clear? Okay, so Prof. Amma, let me finish with this. I'll come, okay, after that, then, okay, you ask your question. Then let's see. So we are looking at what cos, so cos x. Okay, cos, okay, is adjacent over hypotenuse. So adjacent is 5. Okay, now hypotenuse is what? We had the hypotenuse to be 3. Okay, so this one too, if you like, you can change it. That will give you 1 whole number 2 on what? On 3. Okay, all right. Okay, so Prof. Ama Zakuma.
Okay. So please, the first step, finding the hypotenuse. I didn't get to you.
So what did you get?
I got root of 41.
Please, who had the same answer?
I.
You had root
Say
of
I.
41.
Yes, please.
Okay. So it means you are not trying. When I said it, you just took it in. You didn't try. So take note. Okay, as for you using the Pythagoras theorem, it shouldn't be any problem at all. Because this is what we are going to get. Listen, hypotenuse squared. So a squared will be equal to 4 squared, okay, minus what? 4 squared plus what? 5 squared. Am I right?
Yes, please.
Okay, so you see, obviously, something should have told you that your value, when I said h is 3, okay, if you are smart, which I know you are, you should have known that this is wrong. Because if this is 3, remember we said the hypotenuse is what? Is the longest side, true or false?
True.
So how can the longest side right now be not even the second one, but the least? So obviously that should have told you that there is something wrong with what I said. So immediately I say 3, and you see even one value here of the size greater than what? 3. You should know that that value is wrong. So if I've said 7, and maybe you took it to be the answer, right answer, at least I would have pardoned you. Okay, but I cannot say 3 and admit 3 as what? As the answer. All correct.
Yes, please.
Okay, so the point that I wanted to make, okay, here is made. So take note, the hypotenuse will always be the longest side. So on that note, I'm going to clear that. And whatever that I wanted you to know, okay, will come in, okay, pretty soon. Because this question, I wanted us to deal with rationalization. That's the more reason why you have this question there. So it will end up, okay, in that same, okay, so let's go and see. So this gives us what? Root of 41, you said? So root of 41 units. Do you agree? So it will be, this will give us what? 16 plus what? 25. Okay, so 41. You agree? Root of that. Are we good to go?
Yes, please.
Okay, so it means sine x will be equal to what? So this is now root of 41, not 3. Take note. Okay, so sine x will be equal to, we said sine is opposite, okay, over hypotenuse. Our opposite is 4. And the hypotenuse is what? Root of 41. And root of 41 is already in its basic form. Okay, so at this point, you cannot conclude with this. You can't end here. You know, you don't conclude with a fraction containing a set in the denominator. So this calls for rationalization. So you are going to get 4 over 41, root of 41, then times what? Okay, root of 41 over root of 41. All correct. Okay, which in effect will give us what? Okay, 4 root 41, okay, over 41. All correct. Okay, and your trig ratios, they will not have units because it will be your numerator unit over the denominator unit, and they will all have the same unit. So the units will cancel out. Is that clear? All right, we are almost done. So I think with this, you should be able to do that of what? Of the cos. So cos x will be equal to, we said, it will be adjacent over the hypotenuse. So once you're adjacent is 5 over the hypotenuse, which is what? Root of 41. Then you continue, you go and rationalize. You end up getting 5 root of 41, okay, over 41. Is that clear? Okay, so let's move on to the next one. I think this one is similar. It is given in sign, and you are asked to say similar. You are going to look at a situation. This one equally is similar. But this one, you have to be very careful. You can see that this one, the question didn't give you a 1 trig ratio. This one is an equation in 2 trig ratio, sine and cos. Is that not it? Hello? Okay, so take note. Okay, tan. Anytime you have tan theta, okay, this is always equal to sine theta over cos theta. I should have stated this from the beginning. Okay, so in this case, you need to get one. So I can divide through by cos theta. So this will be the approach. Okay, then after that, you should be, that's the first note. After that, you should be able to move on to find. So here, what am I giving? I'm giving, okay, sine x is equal to 2 cos x. So I've not been given a specific ratio, okay, trig ratio. I have two of them. So I can say that this implies that I will divide through by cos because I can see tan in it. If I divide this by cos, cos will go. This by cos, okay, I will end up getting tan. So I will end up getting sine x is equal to 2 cos x, divide by cos x, divide by cos x. Okay, so this means sine x over cos x will give me tan x. Do you agree now?
Yes.
And this will be equal to what? 2. So it means you've been given a triangle. Okay, this will be x. Okay, however, you know tan. Tan is what? Opposite over what? Adjacent. So the opposite will be 2, this over 1. Opposite will be 2, the adjacent will be 1. So you use that to find the hypotenuse and you'll be able to. So the first part of the question, you are through with it. Therefore, tan x is equal. Then the second part will be the hence, where you make use of that. Find the sine x. Not clear.
Yes.
Okay, so now so this one is here. So I will do just one of this, then we are done for the day, where you have more than 2. Okay, the algebra will be a little bit involved. Okay, Prof. Abduma.
Please answer it to move to the previous slide.
Okay, you don't worry because of time. Okay, later you can capture it. We are a little behind time. Okay, thanks for your understanding. Okay, so now let's look at this quickly. So solution to question number 12. What are we giving? We are giving, okay, cos x is equal to 4 on 5. Okay, and again, here, it is your usual angle. You can choose not to, right? This is what we are supposed to find. So before I can find sine x plus tan x, okay, I need to know sine x, its value, and tan x, its value. But sine, like I said, so katoa. Okay, you've been given cos, and cos has adjacent and hypotenuse. Okay, however, sine and tan will need the opposite. So you use the Pythagoras theorem to find, okay, the other unknown sides. So I come and draw my right angle triangle. The angle is still x. So I indicate my x here. Okay, and don't forget to indicate your right angle nature. Cos is what? Cos x, 4 over what? Over 5. Okay, so I am going to get cos. Remember, adjacent is the numerator, and that is 4. So adjacent is 4. Okay, and okay, the hypotenuse is what? It's 5. Is that clear? Okay, so you are supposed to find the opposite. So find the opposite for me. By the Pythagoras theorem, okay, you come and get what? The opposite to be
3.
Okay, it will be 3, the Pythagorean triple. So indirectly, your O will be equal to, and I will always advise, don't introduce, okay, so maybe I can use, the other one, we use A, right? So I can use A or even Y if you like. So A will be equal to what? 3 units. Okay, so once you have that, your work is going to be easy. So now I'll write, okay, therefore, my sine x plus what? Tan x, okay, will be equal to, once I know the opposite, I can find sine x. Sine is opposite over hypotenuse. So my opposite is 3 over the hypotenuse, which is what? 5. Then plus tan x. Tan is what? Opposite over adjacent. Opposite is 3, adjacent is 4. So here you can add. Okay, I hope you get my point. You can continue from here. Can't you? Take the LCM or even use your calculator and write the value there. Is that clear?
Yes.
Okay, so quickly, the next one. Okay, I think I will give this one to you as your assignment. So you try this. Okay, so this will be your assignment. God willing, tomorrow when we meet, okay, we'll look at the sine rule and the cosine rule. Okay, so we'll look at a situation now where our, okay, triangle is not a right angle triangle. Remember I said we can't, trig is not only for right angle triangle, only there's the trig ratios that will be for right angle triangle. But if I have an right angle triangle, how do I, okay, solve that right angle triangle? And that's what we'll do tomorrow. And if time allows, we'll look at our, what do you call it? The test, okay, solution to the test together. Okay, so thank you very much. Okay, bye-bye. Have a wonderful day. And God bless us all for making the lesson a success.